outside ही होगा ना सर, our bezel will be on the both side, correct? जो
Okay,
beam
बेटा.
वाली लाइन रहेगी, वो कैसे,
Okay.
how will you come to whether it's on board or starboard?
अब बेटा अबीम के लिए आपको क्वेश्चन नंबर 2 में आपका जो कोर्स स्टीयर्ड है वो देखना पड़ेगा. द कोर्स स्टीयर्ड इज विस्की टू ऑस्कर, so that seems to be close to 270. Yeah, that's right, 270. So if you are steering 270, your beam bearing is going to be 000, right beta?
Yes sir.
So draw a line from Charlie in the direction of 000 or beam of your ship. Wherever it cuts the line of approach, this particular point is your beam bearing or a beam point.
Sir, doubt any the doubt was it can be 180 also, no, sir. So how do we know whether you have to add 90 or subtract 90s?
Okay, beta. Your ship is here and is steering a course like this. You have to see how does the line of approach crosses your ship. Does it cross you on your starboard beam or it crosses you on your port beam?
Got it, sir. So in all the cases, we have to assume that we have to keep our ship fixed on the center, and then using the relative line of approach, we have to figure it out whether it's on the port or starboard side.
That's correct, beta. That's right.
Okay, so thank you, sir.
और
सर वन
doubts
मोर
बताओ.
थिंग सर,
Go
सर
ahead.
कितना एरर सर एग्जाम में मतलब एक्सेप्टेबल है, जैसे कुछ मतलब 1-2 डिग्रीज और मतलब 5 डिग्रीज, क्योंकि सर कुछ मतलब आंसर्स में सर कुछ मतलब एग्जैक्ट नहीं मैच हो रहा है सर, कुछ एरर है सर.
देखो
तो
बेटा, देखो एरर जो है ये बेसिकली दो चीज़ों पे डिपेंड करता है. एक ही डिपेंड करता है आपके स्केल पे. ओके, द एरर कमिंग इन स्पीड्स एंड डिस्टेंसेस विल बी डिपेंडेंट ऑन द स्केल विच यू यूज्ड. आप अगर स्केल की रेशो को बड़ा कर दोगे, इंस्टेड ऑफ सेंटीमीटर इफ यू यूज इंचेस, और इफ यू इंक्रीज द स्केल, तो आपकी एरर भी बड़ी हो जाएगी. सेकेंड जो चीज़ है जिस पे एरर डिपेंड करती है, दैट इज ऑन द लेंथ ऑफ द लाइन विच यू आर मेजरिंग. द स्मॉलर दैट लाइन इज, द मोर विल बी द एरर. लाइक आई विल गिव यू एग्जांपल. अगर आप इस क्वेश्चन में जाते हो, यू सी पॉइंट W एंड पॉइंट A आर वेरी क्लोज. अब इस केस में बेटा आपकी एरर जो है ये एनहांस हो जाती है. जितने ये पॉइंट पास आते जाएंगे उतना एरर जो है वो बढ़ती जाएगी. सो दिस इज द रीजन देयर इज नो स्पेसिफिक वैल्यू और फिगर विच इज गिवन कि अप टू हियर एरर इज एक्सेप्टेबल. एरर can be present, it will be present in all the calculations what you do. Don't bother about the error, you just bother about that your plot is fundamentally correct and accurate.
ठीक है सर, थैंक यू सर.
Sir, on the radar sheet there are 4 scales given. Do you have to indicate which scale we are using, or just we can write like yesterday you have shown 1 centimeter equal to 1 nautical mile and then we can proceed, sir?
नो बेटा, अगर आपकी रडार प्लॉटिंग शीट पे स्केल्स बने हैं, लेट अस से यू आर सेइंग 4 स्केल्स, आप जो भी स्केल यूज कर रहे हो, यू कैन जस्ट पुट अ टिक मार्क देयर. ओके, इफ यू आर नॉट यूजिंग, if you are not using these scales, then you can mention the scale here as I had done. You can do any of these two methods.
Okay, so if you are not using the scales which are given at the bottom of the sheet, then we have to mention the scale which you are following. Else we
That's
have to
right.
just take it.
That's right. Usually
Okay.
जो plotting sheet पे scales दिए भी होते हैं, one of them is centimeter, another is inches. Okay, these two, usually these are the two scales which are given.
Okay, sir. Thank you, sir.
Okay, beta, great. Very good. So shall we proceed ahead for today's topic?
Yes, sir.
Okay, all right. So I'm closing this down. Let me put up the presentation. Give me a minute. So as I told you, beta, the topics which we are going to do today are tricky and complicated topics. So you need to pay full attention. First, we are going to see how to predict what action is to be taken by our own ship so that we achieve a desired CPA or TCPA. This is exactly what we practically do on board. We see a particular ship, we plot that ship and we see what is the CPA and TCPA. And if we find that the CPA is very less and we need to increase that CPA, we have to take some action. Most of the time in open sea, the action is alteration of course. Another action which is available to us is alteration in speed. Usually in open sea, the preference is always given to a alteration of course in compliance with the ROR. And if you are in restricted visibility, then in most of the cases, the recommendation is given to reduction of the speed of the ship. So how to predict that what action can a particular ship take to attain a desired CPA or TCPA? So this is the first thing which we are going to see. Pay attention, beta. Having understood the basic plotting technique, we are now in a position to progress to our next plotting method, that is predict action to take by own ship. So we have to basically predict the action to take. Action could be a alteration of course and a alteration of speed by own ship to achieve a desired CPA. Now this is what is practically required on board. We need to find out that to obtain a desired result, such as a desired CPA, closest point of approach range, what action has to be taken. The action could be alteration of course, action could be a alteration or variation in the speed. What has to be done by the own ship so that we are able to maintain the required CPA? Or in case you have a collision or a close quarter situation, how should we avoid that close quarter situation? What should be our action? And what are all the possibilities available to the navigator? The possibilities could be, to give you an example, alteration of course to starboard. Another possibility could be alteration of course to port. And the third possibility could be increase or decrease of the speed. So we have to find out what all possibilities are there. And later on, we have to evaluate that as per the rules of the road, collision avoidance rules, which out of these possibilities is the most appropriate in compliance with ROR. Let us now see an example where we are required to take a action for achieving a particular clearance or CPA range. We have the question on the screen. Own ship's course is 055 degrees true, speed 15 knots. Find the CPA, TCPA, course, speed and aspect of the below target. The bearing and range of the target is given. At 0930, bearing is 105, range is 14 miles. After 6 minutes, 0936, the bearing is given as 105 degrees, range is 11.5 miles. And at 0942, the bearing is 104.5 and the range is 8.9 miles. We have to let the target pass ahead with a CPA of 1.5 miles. Find the three possible actions. These could be alteration of courses or speed to take at 9:45. Which of them is most preferable? Now we need to maintain a CPA of 1.5 miles with this target. Important thing to note is that the action is taken at 0945, that is 3 minutes after the last observation. So if you see, the first part of the question is a simple plotting exercise. So on-ship course and speed is given. We have to find the CPA, TCPA, course, speed of the target and aspect. So this is a simple basic plotting question. The second part requires us to predict our action. So let us see how do we do this question. Let us first have the plotting sheet. I have not shown the full plotting sheet so that we can zoom in. We have shown a specific part of the sheet so that we can zoom in and the diagram is clear. Now let us, as usual, first of all mark the scale. The scale which we are using is 1 centimeter equal to 1 nautical mile. Let us now show the center of the plotting sheet as C, Charlie. Let us now show the on-ship course and speed. On-ship course is 055. So you can see the green color arrow marked at the circumference at 055. The speed is given as 15 knots. Speed is also marked. Let us now plot the first observation, first position 0930. The bearing is 105 and the range is 14 miles. So from point C, using the graduations on the circumference at a bearing of 105 and at a range of 14 miles as per our scale, we mark the first relative position of the target. This observation is taken at 9:30, so that time is also mentioned alongside. And as per our nomenclature, this is named as O, Oscar. So we have the first position, relative position of the target on the plot. Let us now mark the second position. You see the second position coming up. This observation is taken at 9:42. We can also plot the 9:36 position. It will be somewhere in between these two observations, but we have not shown the 9:36 position here for clarity. In actual plotting, all the three positions can be shown. You will observe that all these three positions, they fall in a straight line. So we have
is it necessary
shown the
to
0942 position, the final position after the end of the plotting interval. And as per our nomenclature, this is marked as A alpha. Go ahead, beta.
sir, is it necessary to plot all three observations, or first and last will do the trick?
No, beta, plot all three. Most of the time they will be in a straight line. There can be a slight variation. One of the position can be slightly off track. That is because the minimum resolution what we have is about half a degree. So, but you plot all three. If three observations are given, plot all three.
Okay, because if there are multiple targets, say 3 targets also, and we have to plot all three for all of them, and 9.
Plot all three.
Yeah. Okay.
Plot all three, beta. If he's given you three, it is he's basically asking you to plot all three.
Sir, but it will take much more time, na sir?
Not much time, beta. Not much time. 10 or 15 seconds for plotting one position.
Okay.
सर ये सेंटर वाले को भी कुछ नाम देना पड़ेगा क्या सर, लाइक फर्स्ट इज O and लास्ट इज A?
No, not required, beta. Center वाला जो है just plot it there and write the time. No need to give it a name. If we join Oscar to alpha and extend it, this gives us the line of approach. You can see the line of approach coming up. It is represented by double arrows. So you see the double arrows coming up on the line of approach. And you can now drop a perpendicular from Charlie to the line of approach, meeting at the line of approach at point November. November point is our CPA, the closest point of approach. Now, as we have done in our basic plot, from point O, we draw the course of the ship in reverse. You see the green color vector drawn in reverse. The free end of this vector is named as W, Whiskey. Whiskey to Oscar represents on ship course and distance covered in the plotting interval, that is 12 minutes. Now we join W to A, Whiskey to Alpha, and we are aware that this whiskey 2 alpha vector, WA vector, gives us the target's course and distance covered in the plotting interval of 12 minutes. So we can read off the target's course from here. We can measure this distance WA as per our scale, and by interpolation we can find out the speed of the target. So up to here we have done a basic simple plot and we have obtained these answers. The CPA, which is Charlie to November, this distance measured as per our scale, gives us a CPA range of 0.2 miles. We can also find the time to CPA. How can we do that? We measure alpha to November distance, alpha to November divided by Oscar alpha multiplied by the plotting interval, which is 12 minutes. So ship has covered Oscar to alpha distance relatively in 12 minutes. We have to cover alpha to November, and by interpolation we find out the time, and adding this time to 942 gives us the TCPA at 1003 hours. The course of the target WA is measured as 322 degrees true. The speed can be measured using the distance whiskey to alpha WA, and it comes to 20 knots, and the aspect is obtained as 37.5 degrees and it is red. Red indicates that own ship is on the port side of the target ship. So up to here we have done a basic plot. Now proceeding ahead. Since the action is to be taken at 0945 hours, we have to first predict the position of the target ship at 0945. So basis this distance Oscar alpha covered in 12 minutes, we find out the distance which will be covered in 3 minutes, and from point A at that much of distance we mark off the predicted position of the target. Let us name that position as P, Papa. So you can see Papa point coming up on the screen, and we have mentioned the time 0945 along with it. So at 0945 the target is expected to be at point Papa. Now we need to have a CPA of 1.5 miles. So what we do now is we open up our compass equal to this CPA range, that is 1.5 nautical miles as per our scale. We center our compass at point C, point Charlie. With center at C, point Charlie, and radius as our desired CPA of 1.5 miles, we now draw a CPA range circle. So you have the CPA range circle in our plot now. Now what we do is from point P, predicted position of the target at 0945, we draw a tangent to this CPA circle. So from point P, we draw a tangent to the CPA circle. This tangent touches the CPA circle at this particular point. Let's name this point as N1. So you can see November 1 or N1 should be our new CPA point. If the target line of approach becomes Papa November 1, PN1, then you will see the CPA would be Charlie November 1, and which is the radius of the circle, which is taken as 1.5 miles. So to have a CPA of 1.5 miles, the target should move on a relative line of approach PN1, Papa November 1. So this is the new line of approach which is desired. We have shown this using 3 arrows. Now there is one more possibility of drawing a tangent. We can draw a tangent from point P onto this circle in this particular way also. Now why have we picked up the tangent PN1 and not the other tangent? Reason for that is, in the question it is mentioned we have to let the target pass ahead of us. Our ship is steering a course of 055. So our ship steering 055, the target has to pass ahead of us. That means on this particular tangent line, Papa November 1. If we take the second tangent in this particular way and the CPA is somewhere here, with our ship moving on a course of 055, the target would be passing astern of us. So that's why we have not picked up the second possibility of the tangent. Now, since we need the target to follow Papa November 1 line of approach, what we do is we now draw a line from point alpha. From point alpha, we draw a line parallel to the direction of PN1 or NP. That is our new line of approach. So parallel to new line of approach, we draw a line from point alpha. You can use whichever plotting tool you have, set square, parallel ruler or sliding ruler. So from point alpha, we draw a line parallel to our new line of approach, that is Papa November 1. You can see that line coming up. We name the free end of this line as Bravo. So we want the target to move on this line of approach. Now this line alpha to Bravo intersects the own ship course line, that is WO, green color vector, at this particular point. This is the intersection point of the new line of approach and the own ship's course and distance vector WO. Let us name this intersection point as O1, Oscar 1. Now, if you look closely, if our vessel, own ship, covers distance WO1, if own ship covers distance WO1 in a interval of 12 minutes, then in that case, WO1A would become the new relative triangle. If our ship covers a distance of WO1 in a period of 12 minutes, then WO1A would become our new triangle, WO1A. You can follow the laser pointer. WO1A will be our new triangle. And O1 to A will become our new line of approach. And effective from 9:45, this is going to ensure that the required 1.5 miles CPA range is achieved. So this gives us our first option, that is the reduction of speed by own ship. So instead of WO, if we cover a distance of WO1 in 12 minutes, we will be able to attain or achieve a CPA of 1.5 miles. Now we measure this distance WO1 using our scale. So basis this distance WO1 in 12 minutes, we interpolate and calculate the required speed, and the required speed comes out to be 10 knots. So our ship, which is presently moving at 15 knots, if the speed is reduced to 10 knots, on ship target would be WO1, the line of approach would be O1A, and effective from 9:45, this line of approach will result in the vessel CPA coming at point November 1 and 1 and maintaining a range of CPA range of 1.5 miles. Any doubts up to here, beta?
सर ये जो आपने ट्रांसफर किया सर, पी वाला जो PN1 आपने ट्रांसफर किया सर, बैक ट्रांसफर किया ए पे, सर ये
Right.
एक्चुअली हो क्या रहा है सर इस पे एग्जैक्टली, मतलब आप पीछे ट्रायंगल पे क्यों लेके जा रहे हो सर?
ओके बेटा, हो इसमें ये रहा है बेटा कि पापा पॉइंट पे आने के बाद हमारी लाइन ऑफ अप्रोच को हमें चेंज करना है, बिकॉज हमें 1.5 माइल का सीपीए लेके आना है। अब हमें ये देखना है कि हमारी लाइन ऑफ अप्रोच कैसे चेंज होगी। ओके, तो हम ये जो नई लाइन ऑफ अप्रोच है इसे अपनी OAW ट्रायंगल में ले जाते हैं। वी मॉडिफाई दिस OAW ट्रायंगल एंड वी विल सी व्हाट इज द स्पीड चेंज रिक्वायर्ड टू मेंटेन दिस न्यू लाइन ऑफ अप्रोच। अल्फा टू ब्रेवो इज एक्चुअली द न्यू लाइन ऑफ अप्रोच पापा नवंबर 1।
सर अगर यही चीज सर अगर नीचे होता सर, अगर ये सीपीए नीचे को लाइन जा रही होती सर, N1 की जगह सपोज N2 अगर हम नीचे वाला टेंजेंट ले लेते और फिर
Right.
ट्रांसफर करते सर, वो तो ऊपर
Okay,
चले
बेटा।
जाता सर।
नंबर 1 वो हम कर नहीं सकते हैं इस क्वेश्चन में, क्योंकि इन्होंने बोल दिया है कि टारगेट हैज टू पास अहेड ऑफ अस। बट अगर उन्होंने बोला होता कि भाई दूसरा ऑप्शन भी इवेल्युएट करो, तो हम पापा नवंबर 2 जो लाइन बनाते उसे अल्फा पे लेके जाते। इन दैट केस हमें अपनी स्पीड को इंक्रीज करना पड़ता बेटा, बिकॉज द लाइन ऑफ अप्रोच वुड बी गोइंग बियॉन्ड WO। So O1 जो पॉइंट आता that would have been farther away, indicating that is possible by increasing the speed.
तो सर ये जो 10 नॉट्स आया सर, ये 10 नॉट्स आया सर O1W को आपने सर मतलब हमने मतलब देख लिया कितना ये रेंज स्केल में हमने उसको देखा और फिर उसके बाद 60 मिनट से मल्टीप्लाई कर दिया, दैट इज इट।
Exactly बेटा, बहुत सिंपल है। WO1 is covered in 12 minutes। हमें ये पता करना है कि 60 मिनट्स में कितना डिस्टेंस कवर होता है।
ठीक है
सो
सर,
WO1 को
ठीक है
मैयर
सर।
करो और 5 से मल्टीप्लाई कर दो।
ठीक है सर, ठीक, थैंक यू सर।
So it means, sir, it means if you are increasing the speed, then the vessel will pass stern of us. Then there is no possibility for that.
That's correct बेटा, इसीलिए हमने वो सेकेंड लाइन ऑफ अप्रोच बनाई ही नहीं।
तो सर अगर क्वेश्चन में ऐसा दिया रहेगा कि मतलब पॉसिबल 3 एक्शंस, तो कभी कभी ऐसा भी हो सकता है कि एक एक्शन अपने लिए एप्लीकेबल भी नहीं है।
That's right बेटा,
ठीक है सर, थैंक यू।
that's right। मैं वैसी एग्जांपल भी एक करवा दूंगा अभी आपको।
ठीक है सर, थैंक यू सर।
Okay, any more doubts? ओके बेटा, ग्रेट, लेट्स मूव अहेड। एक ऑप्शन हमारे पास आ गया है, दैट इज रिडक्शन ऑफ स्पीड। लेट अस सी अनदर ऑप्शन। Let us now see if we can attain or achieve the desired CPA using an alteration of course also. Now to find out the alteration of course, we pick up our compass. We open up our compass equal to the length of vector WO. This vector represents the distance covered by the ship in a period of 12 minutes. So we open up our compass equal to WO, center our compass at point Whiskey. With center at Whiskey and radius equal to WO, we draw an arc. You can see the red color arc coming up on the plot. Now this arc cuts the line AB, which is parallel to our new line of approach. The arc cuts the line AB at 2 points. One is at this particular point. Let us name this point as O2, Oscar 2, and the other intersection point is this particular point. You can follow the laser pointer on the screen. So this is the second intersection point. Let us name this as O3. Now let us join W to O2 and W to O3. We have joined W to O2 using this vector, the green color vector, and now I am joining W to O3. So we can see WO2 and WO3. Now these two vectors which we have obtained, WO2 and WO3, represent that if our ship moves on course WO2, if our ship moves on a course of WO2 without any change in the speed of the ship, then the new triangle would be WO2A. This is going to result in a line of approach O2A, and effective at 9:45, this will result in the vessel moving on line of approach PN1 coming at CPA at point N1, which is desired CPA of 1.5 miles. Now, if you look closely, the vessel was initially moving on a course of WO. To move on a course of WO2, vessel will have to make a alteration to starboard. So if we make a alteration to starboard equal to angle OWO2, then after this alteration of course, we will be able to achieve a CPA of 1.5 nautical miles. So we now read off the course WO2, and this gives us our new course to steer. Now this is the second option. Now the third option which is available to us is to alter our course to WO through. If we alter our course to WO through, the new triangle would be WO3A. The relative line of approach would be O3A. Again, effective from 9:45, it will make the ship move on a track of P2N1, and this will achieve the desired CPA of 1.5 miles. Now, if the vessel alters its course to WO3, you can see clearly our ship was initially steering WO. We will have to make a port alteration. So, alteration of course to port will result in our course as WO3. The amount of alteration is angle OWO3. We can now place our parallel ruler along with line WO3, use the graduations on the circumference and measure our new course, WO3 course. So when we measure these courses, course WO2 comes as 081 degrees true. This is the first course alteration option to us. And WO3 comes to be 332 degrees true. This is the second course alteration which is available to us. So in all these three options, if we reduce speed to WO1, option number 1, if we alter our course to starboard and start moving on WO2, this is option number 2. And if we alter our course to port and start moving on a course of WO3, in all these three cases, the line of approach is in the direction of B2A. Effective from 9:45, any one of these actions will result, or you can say all three of these actions will result in the ship moving on Papa November 1 new line of approach, maintaining the required CPA, closest point of approach. Any doubts up to here, beta?
Sir, I lost my Wi-Fi connection on those two parts. So, can you please tell sir how you calculated this P for 9:45 and the second doubt is this is the arc which we make for OW. This is the radius for OW we take and it cut on O2 and O3 on the line of approach A and B. Is it the one? Am I right, sir?
That's correct, beta. Your first doubt, how did we obtain point P? See,
Yes,
the
sir,
target vessel covered distance Oscar to Alpha in 12 minutes. So measure this distance, divided by
And
4. We want to find out how much distance will they be covering in 3 minutes.
okay.
So Oscar
By
Alpha
unitary
distance
method we
divided by,
calculated.
that's correct, beta. It is simple interpolation. That's how you
Okay,
calculate P. That's your first doubt. Second doubt is the arc which is made here, the red color arc which you are seeing, its center is point Whiskey and its radius is Whiskey Oscar WO.
okay, sir. Okay. Got it, sir. Thank you, sir.
Any more
Sir,
doubts?
I have a doubt, sir. Sir, deciding the tangent to be drawn on the northern side or the southern side from point P, I always get confused with this.
Okay, beta. If you get confused, what you do is, for your understanding, approximately make a small diagram of the ship at Charlie. Our ship is heading 055. You see this green arrow with 15 knots written?
Yes, sir.
So our ship is heading in this direction, and the question says we have to let the target pass ahead of us. The target should pass from the bow side, not from the stern side. So you see which side the bow is and you make tangent on that side.
Okay, sir. Thank you. Thank you.
Any more doubts?
Also, which is most preferable action?
Okay, I'm telling you that. Let's go ahead and see. So we have three options available to us now. First option is reduced speed to 10 knots, resulting in on-ship vector as WO1. Second option is alter course to starboard to the new course of 081, which is WO2. Third option is alter course to port to a new course of 332 degrees, which is the course of WO3. So with all these three options available to us, we now evaluate the plot, and we are able to observe that these two ships, on ship and the target ship, are crossing with a risk of collision. On ship is also having the target on her starboard side. Now, as per ROR, the crossing situation rule, on ship has to keep out of the way and shall, if the circumstances of the case admit, avoid crossing ahead of the other vessel. So as far as ROR is concerned, none of the three actions contravene or contradict with ROR. All three of them are acceptable as per ROR. However, alteration of course to port is ruled out in this particular case, because if we alter to port, one, it requires a much larger alteration. The amount of alteration which is required is much larger compared to the starboard alteration, and even if you do it, the own ship would have to remain off course for a very long period of time. You see, the rate of approach will become very less. O3A gives you the rate of approach, and our ship will have to stay off course for a much longer period. So alteration to port is not recommended in this case. Now, out of the remaining two possibilities, that is alteration to starboard and reduction of speed, whenever the ship is out in open sea and we have good visibility, in this case there is no mention of any restricted visibility, so we assume there's good visibility, alteration of course is always preferable to a reduction of speed. One, it is easier to do, and second, it would be readily apparent to the other vessel. So out of the three options which are available to us, the most appropriate option would be to alter our course to starboard. The new course would be WO2, line of approach would be O2A. Effective at 9:45, it will make the ship move on the new line of approach, Papa November 1, having its CPA at November 1, which is the required CPA of 1.5 miles. The new course to be steered is 081, effective from 0945 hours. Any doubts coming in, beta?
So for a moment, if we assume that the port alteration was lesser than the starboard alteration, then we could have gone with that.
Yeah, you could have gone with that if the alteration was lesser. But one more thing which you need to keep in mind is also the time for which you have to alter your course. So how can you find out what is the time for which alteration is required? You have to see the line of approach. The line of approach in case of port alteration is O3A. Okay, so in 12 minutes, the vessel is relatively going to move a distance equal to O3A. So you will have to remain off track for a very long period of time. So that will take you a long distance away from your intended track. So that also has to be taken care of.
Got it, sir. Thank you, sir.
सर आंसर में मोस्ट प्रेफरेबल के साथ ये भी लिखना है क्या ओपन सी में या फिर सर
यू शुड मेंशन बेटा रिस्ट्रिक्टेड विजिबिलिटी तो यहाँ कहीं नहीं है. अगर रिस्ट्रिक्टेड विजिबिलिटी सिनेरियो हो जाता यहाँ पर ही, सो इन दैट केस वी वुड सर्टेनली डू द रिडक्शन ऑफ स्पीड बेटा.
ओके सर और जैसे ऐसा क्वेश्चन है जिसमें दिया नहीं है तो दोनों लिख दें क्या फिर इन ओपन सी दिस इज प्रेफर्ड एंड इन
अगर नहीं दिया है देन वी कंसीडर क्लियर विजिबिलिटी बेटा. इफ नथिंग इज गिवन वी कंसीडर क्लियर विजिबिलिटी.
ओके सर
क्लियर बेटा. डन.
डन सर.
Okay.
Sir, just 1 minute, sir.
Go ahead.
You mentioned that, sir, if it was RV, then we have to reduce the speed. But
Right, beta.
as per otherwise, sir, we can still alter to starboard.
Yes. You can do starboard alteration also. There is no other ship which is there in the scenario, so you can do a starboard alteration also. No issues. Both options will be available.
Thank you, sir.
Okay, beta. Great. So I'm closing the presentation. This basically takes care of predicting action to take. ओके. अब बेटा मुझे एक बात बताओ कि हमारा ये पहला सब टॉपिक था आज के लिए, हाउ टू प्रिडिक्ट व्हाट एक्शन इज टू बी टेकन. नाउ कैन वी गो ahead to the next topic or you want to take a 5 minutes break?
5 minutes.
ठीक है बेटा, 5 मिनट की ब्रेक लेते हैं. देन वी कम बैक. देन आई एम गोइंग टू शो यू मल्टीपल टारगेट्स नाउ. अभी एक टारगेट था, विल मेक 2 1 3. सो बी बैक आफ्टर 5 minutes.
ओके सर.
Okay, sir. Thank you, sir.
हेलो देवी कैसी चली हुई टीम आपकी? ऐसे ही है. खोल ही लिया था आपने हैं? तो ठीक नहीं चलो इथों सारे प्लेयर खरे खेल ले. पाटीदार थोड़ा ऊपर निकला हुआ. हाँ अब रैंकिंग कितनी भाई है? रैंकिंग पॉइंट नहीं और आंदी नहीं कितना रैंक चलूगा. कॉन्टेस्ट से जावा ना. हाँ थोड़े कितने पॉइंट देखने भाई 800 थोड़े कितने. हाँ नहीं ऊपर सज्जे पास जिथे रैंक दसो ना इससे थोड़े ऊपर है लिखो होना नेटवर्क करने ऑप्शन बनू होना सिंबल जेती क्लिक कर फिर आ जाना रैंक. ਉੱਥੇ ਆ ਜਿੱਥੇ ਰੈਂਕਿੰਗ ਹੋਦੀ ਨਾ ਤੁਹਾਡੀ ਤੇ ਥੋੜੇ ਉੱਪਰ ਹੋਣਾ. ਅਨਿਆਦ ਉੱਪਰ ਜਾਣੇ ਨਹੀਂ ਤਿੱਥੇ ਨੀਚੇ ਹੀ ਤਿੱਥੇ ਰੈਂਕਿੰਗ ਵਗੈਰਾ ਹੋਦੀ ਨਾ ਤੁਹਾਡੀ ਤੇ ਜਰਾ ਉੱਪਰ ਹੋਣਾ ਹਲਕਾ ਜਿਹਾ. ਰੁਕਾਇਆ ਹੋਗਾ. हेलो हाँ जी अम्मी कुत्थे पहुंचे अच्छा अच्छा तो थे पूजा टाइम में पहुंचना कि नहीं अद्धे घंटे पहुंच जाना ना
Okay, beta, are we back?
अच्छा ठीक है कर है बोलिंदा
Yes, sir.
चलो ठीक है ओके
Yes, sir.
Okay, great, beta. Very good. So, beta, we have now understood the concept of how can we find out what is the action to be taken to attain or achieve a desired CPA. Now we did this with a single target. Now we are moving on to multiple target scenarios where you could have two targets or three targets, and you have to take action so that you clear all of them at once. So the first doubt which comes to our mind is that if we have two targets, in single target we could make this CPA circle new line of approach, and we could modify the OAW triangle. Now in two target scenario, first doubt which comes to mind is with which target we should do that modification, target A or target B. So first we need to make one of those targets as our priority target. So we will see now how a target is made as a priority target, or you have to pick up a target which poses a greater threat to you. So we will first see how the priority target is picked up, and then we will see that basis this priority target, how do we take action. And once we take action basis our priority target, we have to check that action with the other target also. 90% of the time, if you take action basis the priority target, it will clear the other target automatically. But in few questions, 5 or 10% of the questions, it is possible that if you take action basis priority target, you may still have a close quarter situation with the second target. So in that case, you will have to redo the calculation with the second target. So these are the most complicated questions which come in our exams, and these are the types which are most frequently appearing in the exams. So let us see this type beta. So let me put up the presentation.
Does this light vessels and any floating objects comes under traffic, sir?
No, this will not be considered traffic beta. Traffic will be only moving targets.
Because in some of the questions they mention mention CP of 2 miles from all the passing traffic. So it means only vessels. If it is a fixed object, then we don't have to worry.
Yeah, that's right, beta. If he's mentioned the word traffic, in that case it will be only from moving targets.
But it's then in which case we have to consider these floating objects and other objects which are not vessels.
Then he will say you have to keep a CPA of 1.5 nautical mile from all objects.
Got it. Thank you, sir.
Then he will not mention the word traffic.
Got it. Thank you, sir.
Okay, all right. Now, having understood a basic plot and having seen the method to predict the action to be taken by ownership, we are now ready to go into the questions involving multiple targets, more than one targets. So this very nearly corresponds to the practical situations which we face on board. We may have multiple targets close to us, and we may be required to take action following the ROR. Now, when we are having multiple targets, more than one targets, the main question or main doubt which arises is that our action should be basis which of the three targets, which of the two targets or three targets. So for that, in case of a close quarter situation developing with multiple targets, we follow the priority like this. In case of targets with different TCPA, that is the time for closest point of approach, the earliest earlier occurrence poses a greater risk than the later one. So we check the TCPA of all the targets. The target having the minimum TCPA, which means earliest occurrence, that target poses the greater risk than the one whose TCPA is occurring at a later time. Now, in case we have multiple targets with similar TCPA, both the targets or all three of the targets are having a similar TCPA, the one with a closer CPA poses a greater risk to us. Now, once you find out or pinpoint the target which poses a greater risk, the target that poses a greater risk would require an action of greater magnitude. Hence, during evaluation, choose the action suitable for the greater risk target and then check this action suitability for other targets also. This will ensure that the vessel maintains its required CPA with all the targets which are there close to us. So with this, now let us proceed to few questions having multiple targets and see how do we solve them. Any doubts in this, beta? Great, very good. So we have our next question on the screen now. The question says, on ship's course is 240 degrees true and speed of 15 knots. In restricted visibility, observes the following two targets, target C and D, target Charlie and target Delta. First observation is made at 1000 hours. The bearing of target C, target Charlie is 314 degrees true and the range is 11.9 miles. For target Delta, the bearing is 208.5 degrees true and the range is 10.0 miles. The next observation is taken after 12 minutes at 10:12. The bearing of target C, Charlie, remains 314 and the range is 8.3 miles. The bearing of target D, Delta, is 211 degrees true and the range is 5.1 nautical miles. We have to find the CPA range, CPA time, course, speed and aspect of these targets at 10:12. Master decides to take action at 10:16 to have a minimum CPA of 2 nautical miles. Evaluate the possible alternatives available to the master and explain which of them is most preferable. Now, some important points from the question. First thing which we notice is that the ship is in a restricted visibility area. So we have rule number 19 in force. The second thing which we notice is target Charlie has its bearing as 314 at both the observations and the range is reducing. So the target Charlie is on a collision course. So the first part of question is exactly what we have done till now. So let us first plot these two targets and find out the CPA range, time, course, speed and aspect of both of them. Let us first have the plotting sheet. We have the plotting sheet on the screen now. Let's mark the center of the plotting sheet as C, Charlie. Let's mention the scale which we will be using. The scale is 1 centimeter equal to 1 nautical mile. Let's now mark the course and speed of own ship. Own ship is steering 240, So you see the green color arrow coming up on the circumference of the plotting sheet at 240. Speed is 15 knots, so speed is also marked. Let us first plot the target C, target Charlie. The range is 11.9 miles and the bearing is 314. So on a bearing of 314 at a range of 11.9 miles as per our scale, we plot our first position, and this position is applicable for 1000 hours. We mark the time along with the position, and this is named as O, Oscar. Let's plot the second position. We have the second position here. The bearing remains the same, 314, and the range is now 8.3 miles. This observation is taken at 1012 hours, and as per our system, the point is named as A, alpha. Now let's join the line OA and extend it. Oscar alpha line is joined and extended, and this gives us the relative line of approach of target Charlie. We can see the relative line of approach is passing exactly from the center or from the own ship position, indicating that the target is on a collision course. Let us now plot own ship's course vector. So from point O, in the reverse direction of our course, we mark off this green color vector, O to W. Now WO represents own ship's course and distance steamed in the plotting interval of 12 minutes. Now if we join W with A, whiskey with alpha, WA vector gives us the course and the distance covered by the target within the plotting interval. So we have the WA vector representing the course and the distance covered by the target in the plotting interval from 1000 hours to 1012 hours. So the information what we obtain from plotting is target Charlie is on a collision course. We can also find out the time. The time can be found by measuring distance alpha to Charlie divided by Oscar to alpha multiplied by 12. So Oscar to alpha distance is covered by the target in 12 minutes. We find out how much time would the target take to come to Charlie, and that would give us the time to CPA. So we obtain from the plot target Charlie is on a collision course and the collision is predicted at 1040. The course of the target Charlie is 180 degrees true and the speed is 20 knots. WA distance has been covered by the target in 12 minutes. So interpolating for 1 hour, we get the speed as 20 knots. We also obtain the aspect. The aspect in this case is 46 degrees red. That means we are 46 degrees onto the port side of the target Charlie. Let us now plot our second target Delta. For target Delta, the first bearing is 208.5, range is 10 miles. So on a bearing of 208.5, at a range of 10 nautical miles, we plot the first relative position of target Delta. This is applicable at 1000 hours and we name that position as O, Oscar. The second bearing is 211 degrees true. So at a bearing of 211, the range is 5.1 nautical miles. As per our scale, at a range of 5.1 nautical miles, we plot the second position of the target Delta. This is taken, observation is taken at 1012 hours and this position is named as Alpha. Now we join Oscar to Alpha and extend this line. Oscar to Alpha line extended gives us the relative line of approach. Now from point Oscar, we mark our own ship course and distance in the reciprocal direction, in the reverse direction, You can see the green color vector coming up. The free end of the vector is named as W, whiskey. Whiskey to Oscar represents on ship scores and distance covered in the plotting interval of 12 minutes. Now, if we join W to A, whiskey to alpha, this vector whiskey to alpha gives us the course and distance of target delta. So we can measure off the course and distance of the target delta from WA vector. So when we measure this information, obtain this information, we come to know that the CPA for target delta is 0.4 nautical miles. You can see this is the CPA here. You have to drop a perpendicular from Charlie to the relative line of approach. That will give you the CPA. The CPA is 0.4 miles and it is happening at 10:24. Again, we can measure the distance between alpha to the CPA point. Now the ship has covered a distance of Oscar to alpha in a interval of 12 minutes. Interpolating for this distance, we can find out what is the time at which the CPA would occur. And in this case, the CPA time comes to 1024 hours. We can measure the course of the target by the direction of WA, and the course comes out to be 351 degrees true. We also know the target has covered a distance of whiskey to alpha in 12 minutes. So interpolating it for 1 hour, we get the speed of the target, which is 15 knots. We also find out the aspect of own ship. So the angle between the heading of the target vessel and the bearing of our own ship from the target, that comes to 40 degrees and it is green because our ship falls on starboard side of the target. So first part of the question is done. We have plotted both the targets. We know their CPAs, DCPAs, the course and speed of the target is known and the aspect is also known. Now we can see here from the information what we have obtained. This question is set up in restricted visibility. So vessels are not in sight of one another. Now as per rule 19, any of the three ships is free to take any action to avoid a close quarter situation. However, we can observe here that each ship has the other two ships forward of her beam. You can consider any particular ship. You can consider target Charlie. Both the other ship, own ship as well as target delta, are forward of her beam. You can consider target delta. Both our ship, own ship as well as target Charlie is forward of his beam. And you can consider own ship at Charlie. Both the ships, target Charlie as well as target delta, are forward of our beam. Hence, as per rule 19, none of the three ships is permitted to alter course to port. So, in view of this, own ship is having only two options which are available to the master. One is a alteration of course to starboard, and the second is a reduction of speed. So we will now evaluate both these actions and we will see which of them is most preferable and recommended in this situation. Now, how should we evaluate the action? Which target shall we take to evaluate the action? Should it be target Charlie or should it be target delta? Now, if you have a look at CPA of both the targets, that is indicating either a collision with target Charlie, and with target delta, the CPA is very less, that is 0.4 miles. So there is no major difference in the CPA. But if you have a look at their TCPA, the time to closest point of approach, the TCPA for target Charlie is happening at 1040, whereas for target delta it is happening at 1024. that is about 16 minutes before target Charlie. So since the CPA with delta is happening 16 minutes earlier, we will take a action to have a CPA of 2 nautical miles or more for target delta, because target delta has the priority over target Charlie because of the frequent or earlier TCPA. So we will first evaluate our action basis target delta, and then we will check this action for target Charlie. Now, since we need a CPA of 2 nautical miles, let us first plot this CPA circle, keeping our compass at the center of the plotting sheet at point C, point Charlie. I open up my compass equal to 2 nautical miles and draw my CPA circle. So we have our CPA circle. Now the question says that the action is to be taken at 1016 hours. So let us first predict the position of target delta at 1016 hours. We know target delta has moved from Oscar to Alpha in 12 minutes. So interpolating it for 4 minutes, we can obtain the location of target delta, predicted position of target delta at 1016. So you can see the predicted position P Papa coming up on the plot. Now from Papa, I draw a tangent to my CPA circle. You can see this tangent coming up. Now there are 2 possibilities for drawing the tangent. You can see the first possibility, Papa to November 1. The second possibility is on the other side of the CPA circle. You can see the second possibility now, Papa to November 2. So if our line of approach from point P, from point Papa, changes over to Papa November 1, we will have a 2 mile CPA. Or the other option is that if our line of approach changes over to Papa November 2, we will again have a 2 miles CPA. So there are 2 options which are available to us. CPA can occur at November 1 or November 2. So let us evaluate these 2 options one by one. So what we do first is we pick up the line of approach Papa November 1. We align our parallel ruler to this particular line, take our parallel ruler to point Alpha and draw a line parallel to our new relative line of approach, that is Papa November 1. So you can see this line coming up on the plot. Now what I do is I open up my compass equal to WO, Whiskey Oscar, for target delta. Center my compass at point W, Whiskey point, and draw an arc. You can see this red color arc coming up on the plot. The arc is centered at Whiskey and the radius is equal to Whiskey Oscar. Now this arc intersects our new relative line of approach at this particular point. So let us name this particular point as Oscar 1.
Hello?
Now we join W to Oscar 1.
ठीक okay.
You can see the W to Oscar 1 vector coming up. Now this W to Oscar 1 gives us our first option. If the ownership course becomes W Oscar 1, then the triangle which we will have will be W Oscar 1A. The relative line of approach will become O1A, and effective at 1016 hours, that is at point Papa, this relative line of approach will take the target on Papa November 1 track, and when it reaches at November 1, it will have a CPA of minimum 2 nautical mile. Now we align our parallel ruler or set square or sliding roller to W Oscar 1 and measure this course using the plotting sheet as a compass rose. We measure the course and this comes to a course of 317 degrees true. 317 degrees true. So if own ship alters course to 317 degrees true, initial course is 240, so that's an alteration of 77 degrees to starboard. If our ship alters course to 317 degrees true, effective at 1016, the target will have a CPA of 2 nautical mile at point November 1. Now, beta, a couple of things before we proceed ahead. First thing is that this diagram is made digitally. So if you plot it actually using the geometry tools, your diagram may not exactly match with this. Okay, so there can be slight variation, slight distortion in the diagram. That's first thing which you keep in mind. Second thing is beta, that in this particular scenario, if you see, there is no option available to us by reduction or increase of our speed. If you reduce your speed, no matter how much you reduce your speed, in no way you will be able to achieve this line of approach. So the change in speed option in this particular case is not available to us at all. WO vector, the green color vector which we have, even if you reduce the magnitude of WO vector, the line of approach does not intersect the WO vector at any point. So this is the only option, alteration of course to starboard in this particular scenario. Now, any doubts coming up to here, beta?
So the scenario that we are talking about is, sir, the scenario that we are talking about is that the target ship is crossing from N1.
That's correct, beta. N2 we have not evaluated yet. We will evaluate N2 later.
Correct. Okay.
So here the initial course of target D was 351 degrees, sir. And if you alter the course by 77 degree to starboard, then the new course cannot be 317 degree because 351 plus 77, it will be something like say 70 degrees, sir. Something.
Okay, beta, the target delta is not altering course. We are altering course. Our course was 240.
Okay. Sorry, sir. Got it, sir. Thank you. Sir.
Okay.
सर वो रिडक्शन ऑफ स्पीड तभी होता है सर जब OW कट हो रहा होता है सर, जो हमने
That's correct,
ट्रांसफर
beta.
किया सर.
That's
अगर
correct.
OW पे कट होता तभी रिडक्शन ऑफ स्पीड हम केस लेते सर.
That's correct. You see alpha O1 line, जो blue color की line हमने ट्रांसफर की थी at point alpha, अगर वो line WO वेक्टर को कट करती, तभी हमारे पास रिडक्शन ऑफ स्पीड का ऑप्शन अवेलेबल होता.
ठीक है सर.
Sir, simultaneously I have also been plotting here, sir, but वो कट ही नहीं हो रहा है, sir. मतलब जो ये पेज को तो ट्रांसफर किया सर, बैक ट्रांसफर किया तो वो सर्कल में कट नहीं हो रहा है.
आपका जो सर्कल है, this must be touching very close to A.
थोड़ा सा मतलब बाहर की तरफ चला जा रहा है, सर. It's out of the circle. Tangent नहीं हो पा रहा.
That may be because of plotting error. इसीलिए मैंने बोला कि ये digitally created है ना, so this will not replicate it. Okay. अगर इसकी actual drawing चाहिए, मैं actual drawing भी आपको भेज दूंगा.
जी सर, ठीक है सर. बट ऐसे केसेस में फिर क्या करना है? फिर से मेरी कंफर्म करना है क्या सर कि जहाँ पे कट नहीं हो रहा है तो?
नहीं बेटा, it will match because देखो आपका जो WO वेक्टर है ना, your speed is 15 knots ना, 15 knots, and जो target delta की speed है, that is also, if you see, it has come to 15 knots.
Yes sir.
Okay, so WO and WA will be matching and your circle will touch very close to point A.
जी सर, वही हो रहा है.
Okay, it will touch. So don't worry, आपका आंसर करेक्ट आएगा बेटा. The diagram will not match but the answer will be correct.
Okay, thank you.
सर मैं ये पूछ रहा था, एग्जाम पेपर में अपने को PN1 एंड PN2 दोनों शो करना है वहां पे?
दोनों शो करना है बेटा.
सर बट N2 क्यों शो करे सर? क्योंकि रिस्ट्रिक्टेड विजिबिलिटी का केस है, तो इन एनी केस फॉरवर्ड ऑफ द बीम वी आर नॉट सपोज्ड टू अल्टर द कोर्स टुवर्ड्स द टारगेट.
अब बेटा अभी तो हमने देखा ही नहीं कि N2 जाने के लिए स्टारबोर्ड ऑल्ट्रेशन है या पोर्ट ऑल्ट्रेशन है या रिडक्शन ऑफ स्पीड है. तीनों में से कुछ भी हो सकता है ना.
Reduction of speed, yes.
वो तो अभी चेक करेंगे.
ओके सर.
ओके.
सर और एक चीज, सपोज जैसे कि अभी डेल्टा के साथ मैंने टीसीपी देखा, मेरा नजदीक है और मैंने डेल्टा के साथ अल्टर कर दिया. नाउ द अल्टर्ड कोर्स WO1, do we have to do the same thing with the target C also, changing the WO1 over there, and we have to replicate there in the answer sheet?
अभी मैं करके दिखाता हूँ बेटा आपको. अभी ये जो ऑल्ट्रेशन हमने यहाँ डेल्टा से निकाली है, वी विल चेक इट फॉर चार्ली. वी विल चेक इट नाउ.
जी जी.
Now let us evaluate the effectiveness of this action for target Charlie also. So what I do is at point whiskey, now I draw my new course. My new course would be 317 degrees true. So you can see this green color vector coming up, and let us name this as O1, this point, the free end of the vector. Now if I join O1 with A, this is going to give me the new relative line of approach for target Charlie. So the length of WO1 is exactly same as WO. There is no change in our speed. So this is indicated by this arc also here. Now we join Oscar 1 to alpha. This will be our new relative line of approach. Since this is effective at 10:16, so let us first predict the position of target Charlie at 1016 hours after 4 minutes. So interpolating this difference, the distance Oscar to alpha is covered by target Charlie in 12 minutes. Interpolating, we obtain the predicted position of target Charlie at point P here. Now we transfer the new line of approach, that is Oscar 1 alpha to point P. So you can see a line parallel to Oscar 1 alpha coming at point P. This will be the new relative line of approach for target Charlie. You can see 3 arrows coming up. 3 arrows can be shown to predict the new relative line of approach after a action is taken. Now our CPA will be occurring at this particular point, November 1 here. You can drop a perpendicular from Charlie to this new relative line of approach for target C, and this meets here at November 1 point, and it tells us that the CPA for target Charlie will be more than our required value of 2 nautical miles. So this indicates that this action of alteration of course to 317 degrees true will make the CPA of both the targets more than our required CPA of 2 nautical miles. So this is the first option which is available to us. Just have a good look on this beta. Give me a minute. I'll be back. Just have a good look.
भाई एक बात बताओ. हेलो, सुन रहे हो?
बोलिए.
अरे मैं ये कहता, अगर हम लोग को पहले ऑप्शन में ही अगर हमें ऐसी कंडीशन मिल जाती है जो सारे हमारे क्राइटेरिया को मीट करती है, तो हमें दूसरे ऑप्शन को चेक करने की जरूरत है.
बिल्कुल जरूरत है भाई, क्योंकि आपके ऑल्ट्रेशन के बाद हो सकता है कि जो दूसरे वाले टारगेट है उससे आप मैच नहीं कर पा रहे हो, इसलिए दोनों को वेरीफाई करना बहुत जरूरी होता है.
अभी तो हमने वेरीफाई कर लिया ना, अभी ये दोनों टारगेट को मीट कर रहा है. 2 माइल
वो सिर्फ दिखाने के लिए कि ROR को कंप्लाई कर रहे हैं. हम लोग ऑल्ट्रेशन पोर्ट में नहीं कर सकते क्योंकि रूल नंबर 19 है, इसलिए एक N2 का लाइन खींच के दिखा देना कि N2 का लाइन खींचने से आई हैव टू ऑल्टर पोर्ट. तो वो मतलब तुम्हारा सेकंड क्राइटेरिया जो है ना, मतलब वो सिर्फ स्टेटमेंट बनाने के लिए.
नहीं रिक्वायर्ड नहीं है भाई, अगर जो जो एक्शन आप नहीं ले रहे हो आपको दिखाने की जरूरत नहीं है शायद, जहाँ तक मुझे ही मालूम कि कोर्ट में आप ऑर्डर कर ही नहीं सकते, दैट इज
बट N2 के लिए अभी पता कैसे चलेगा कि हमें पोर्ट ऑल्टर
N2
करना है? अभी नहीं पता।
N2 रिडक्शन ऑफ
N2 का
स्पीड भी
अप्रोच
होगा।
दूसरी तरफ हो जाएगा ना, ए से PN2 को ए पे लाएंगे तो फिर वो WO का डिस्टेंस लेकर के जहां आपको कट करेगा PN2,
दैट विल बी रिडक्शन ऑफ स्पीड हो जाएगा फिर।
रिडक्शन ऑफ स्पीड भी हो सकता है और ऑल्टरेशन टू पोर्ट भी हो सकता है, दोनों केसेस उसमें है।
हाँ सही बोल रहे हो आप, रिडक्शन ऑफ स्पीड भी हो सकता है, ऑल्टरेशन ऑफ कोर्स टू फोर्थ भी हो जाए, बट बोथ अलाउड नहीं है। रिड्यूस आप कर सकते हो बट डिपेंड्स कि अगर स्ट्रॉन्ग करंट है तो फिर शायद, बट हो सकता है कि जब आप रिड्यूस स्पीड करोगे तो दूसरे वाले टारगेट से मैच नहीं कर पाएगा, इसलिए दैट एक्शन कैन
वो जो रिड्यूस वाला केस होगा ना वो बहुत ज्यादा रिडक्शन होगा, इसीलिए शायद एप्लीकेबल नहीं होगा, बस चेक करना पड़ेगा।
हाँ, मैं ये पूछ रहा
कर
था
सकते हैं बट आप वेरीफाई कर सकते हैं।
मैं ये पूछ रहा था कि सर एक चीज बस पूछ रहा था,
हाँ,
हम
go
लोग
ahead,
यही
बेटा,
डिस्कस
बोलो।
कर रहे थे कि अगर जैसे पहले कंडीशन में ही हमको ये सारी चीजें मिल गई कि जहां हमारे सारे क्राइटेरियाज मीट कर रहे हैं विद ऑल द टारगेट्स ऑन द
राइट बेटा, राइट।
तो हमें दूसरे ऑप्शंस को एक्सप्लोर करने की जरूरत होती है।
हाँ बेटा, एक्सप्लोर करना पड़ेगा बिकॉज दिस ऑप्शन ओके एक्सेप्टेबल कि ये अगर एक्शन हम लेते हैं तो बोथ टारगेट्स आर गेटिंग क्लियर एज पर अवर क्राइटेरिया, बट हो सकता है जो दूसरा ऑप्शन हमारे पास आए दैट मे बी बेटर देन दिस, सो वी विल हैव टू कंपेयर बोथ ऑफ देम एंड पिक अप द बेस्ट ऑफ द टू।
ओके
सर टारगेट सी में अपना ये AO1 का कैसे आया था सर?
ओके O1 कैसे आया? देखो बेटा, हमने जो टारगेट डेल्टा पे नया कोर्स निकाला, WO1 कोर्स वेक्टर आ गया ना हमारे पास फ्रॉम टारगेट
Yes, sir.
डेल्टा, we transferred this WO1 vector to target Charlie. We made the same WO1 vector at target Charlie also. Did you understand that? How did we get WO1 for Charlie?
नहीं सर अभी भी नहीं आया सर ये।
Okay beta, okay. You got the vector WO1 for delta. Pay your attention at delta.
Yes sir.
By our plotting, we have obtained WO1 from delta. We know what is the direction of WO1. We know what is the magnitude
Yes,
of
sir.
WO1, right?
Yes sir.
Now you come to target Charlie. From point W, you draw the same vector, same direction WO1 and
Okay,
same
sir.
magnitude WO1. You get the O1 point
Okay,
for
sir.
Charlie. Right, beta?
Okay
Got
sir.
it?
Yes sir.
So
Yes,
once
sir.
you get the O1 point, you will get O1A, which will be the line of approach. Transfer it to Papa point of target Charlie, and you get the new line of approach.
Okay sir.
Okay, great. Any
Sir.
more doubts up to here?
Yes, sir. Sir, I have understood the full question, but
Okay.
only one thing I have a doubt regarding the aspect 40-degree green of target delta. तो सर
Right.
ये थोड़ा सा बता दीजिएगा सर, वो ग्रीन लाइट का क्या सीन, क्या
ओके बेटा, बहुत सिंपल है। 40 डिग्री ग्रीन कैसे आया? देखो टारगेट डेल्टा को देखो बेटा, जो मैरून कलर का वेक्टर है विस्की टू अल्फा ऑफ टारगेट डेल्टा, दिस रिप्रेजेंट्स हाउ टारगेट डेल्टा इज हेडिंग.
ओके सर.
Okay, your ship is at Charlie. Now the angle between the heading of the target delta and bearing of your ship from delta, that is alpha to Charlie, is the aspect. Correct?
Yes sir, 40 डिग्री वो निकल गया सर.
And starboard कैसे आया? You are on starboard side of target delta beta, that is why it is green. Did you get that? How did we get green?
No sir, no.
Okay
So our
beta.
course is 240.
Suno,
Sir,
suno.
our course is 240.
No, don't bother about our course. Our course does not matter in aspect. What matters, imagine that you are standing on target delta. Okay, you are the duty officer on target delta. Time is 1012. Okay,
Okay sir.
you are heading in a direction of 351. 351 is your course, right?
351. Okay sir.
and you see a ship which is located at point Charlie. This ship will be on your starboard side or on your port side?
Sir, starboard side.
Exactly. So that is what decides whether the aspect would be green or red. If your ship is on starboard side of the target, the aspect would be green. If your ship on port side of the target, the aspect would be red.
Understood, sir. Understood. Thank you.
चलें आगे बेटा. Up to here clear?
Yes, sir.
Great, very good. So we have evaluated one option. Fortunately, it is satisfying the condition for both the targets Charlie and Delta. Now let us explore other options. Now let's see the second option. The second line of approach which we had, the second option was Papa November 2. Papa November 2. So we can now draw this second line of approach, Papa November 2, from point alpha. So I align my parallel ruler to Papa November 2, take it to point alpha and draw a parallel line. So you can see this parallel line coming up here. This is for target Delta. So this can be the second option for our relative line of approach. Now this new relative line of approach from point alpha intersects our WO vector. WO vector, it intersects at this particular point, and let us name this point as O2. So now you see, if our speed is reduced so that in 12 minutes we do not cover a distance of WO, but instead we cover a distance of WO2. You can see this WO2 vector. If we cover a distance of WO2 by reducing our speed in 12 minutes, our triangle would be WO2 alpha. And in this case, O2 alpha would become our relative line of approach. Transferring this approach to point P, that is 1016 hours, we will have the line of approach like this. The line of approach will take the target ship Delta at its CPA at point N2. So again, target Delta will have its CPA at point N2, November 2. Now we measure this distance WO2. This distance has to be covered in 12 minutes. We interpolate for this for a period of 1 hour, and that gives us our new speed. And the new speed of our ship comes to 2 knots. So if we reduce the own ship speed to 2 knots, WO2 will be the own ship vector, O2A will be the relative line of approach, effective at 1016, that is at point Papa. This will take the target to Papa November 2 line of approach. CPA would occur at November 2 and it will be 2 nautical miles. So this is the second option which is available to us. Go ahead, beta.
Sir, can you repeat one more time?
Okay, where is the doubt coming in, beta?
सर ये जो आपने मेंशन किया reduce the speed to 2 knots और WO2 ये सर एक बार फिर से रिपीट करेंगे क्या?
Okay,
Yes, sir.
alright.
Yes, sir.
Okay, repeating once again, beta. See, our line of approach was Papa November 2. What we do is, this Papa November 2 line is extended from point A of Delta target. So you can see a line which is extended from point A parallel to Papa November 2. This particular line cuts the WO vector at point O2. Can you see point O2 here at Delta?
Yes, sir.
Okay, so this basically tells us that if we cover a distance equal to WO2, then we will be able to make a line of approach going from Papa to November 2. So this is how you obtain the reduction in speed. Clear, beta? Got it?
Yes, sir. Now clear, sir.
Okay, all right. Let us now check the effectiveness of the second option, that is reduction in speed for target Charlie. So let's do that. Our initial ownership vector was Whiskey to Oscar, WO. Now we modify the length of this vector as per our new speed of 2 knots. And this is modified now to WO2 here. You can follow the laser pointer, W2O2. This is the new ownership vector. Now from O2, I join a line with point alpha. You can see Oscar 2 to alpha dotted line coming up. This will be the new relative line of approach for target Charlie. This is effective at 1016 hours. So transferring this line O2 alpha at point P, which is the predicted position at 1016, we have our new line of approach. So you can see this dotted line from point Papa of target Charlie showing up on the screen, and we can clearly see that the CPA of target Charlie has increased from its initial value. So it is much more than 2 nautical mile, which is the required CPA. So we have now seen that this is the second option which is available to us. Reduction of speed. If we reduce the speed to 2 knots, both the ships will have a minimum CPA of 2 nautical miles. Any doubts up to here?
सर आंसर शीट में जो थियोरेटिकल जो आंसर शीट है सर उसमें पी का कैलकुलेशन सब दिखाना है, जैसे वी आर इंटरपोलेटिंग फॉर 4 मिनट्स सो एंड सो स्पीड डिवाइड टाइम करके ऐसे करके सब इंटरपोलेशन दिखाना है आंसर शीट में, या डायरेक्टली वी कैन डू
better show these calculations beta.
Okay sir.
Okay, you don't have to write the steps, that how you are taking point P, how you are taking A, how you are taking W. No need to explain the procedure or the steps, but show these calculations.
Okay sir.
सर ये जो आपने
कोई ऐसा है कैसे, मतलब जिसपे स्टेप बाय स्टेप प्रोसीजर लिखा होगा, मतलब दैट विल बी गुड फॉर अस रेफरेंस.
यही the some predefined steps to follow in answer sheet, मतलब इसके बाद ये ऐसे लिखने का प्रोसीजर.
ओके बेटा, देखो जो मैंने यहाँ इस शीट पे दिखाया है इसमें तो काफी कुछ लिखा हुआ है, सो दैट यू कैन रीड इट एंड अंडरस्टैंड इट एज वी सॉल्व द क्वेश्चन. बट आपको जो अपनी आंसर शीट में दिखाना है उसके लिए एक माइंड में प्रिंसिपल याद रखो बेटा. प्लॉटिंग करने के टाइम पे जो भी चीज आपको कैलकुलेट करनी पड़े, एनीथिंग विच यू नीड टू कैलकुलेट ड्यूरिंग प्लॉटिंग, दैट हैव टू बी शोन इन योर वर्किंग. ओके, आपने पॉइंट O को प्लॉट किया, नथिंग इज टू बी शोन. आपने पॉइंट A को प्लॉट किया, नथिंग इज टू बी शोन. द इंफॉर्मेशन वाज गिवन इन द क्वेश्चन इटसेल्फ. बट आपने प्रेडिक्टेड पोजीशन को यहाँ पे प्लॉट किया. हाउ डिड यू गेट डिस्टेंस A to P? This calculation should be shown. So remember in your mind, anything which you are doing in your calculator for plotting purpose has to be shown in the answer sheet.
सर बेसिकली जो हमारा चार्ट वर्क में करते थे वो इसमें करना है ना, सिंपल सा.
एग्जैक्टली सेम फंडामेंटल है चार्ट वर्क बेटा. आप चार्ट वर्क में जब क्वेश्चन करते हो यू डोंट एक्सप्लेन द प्रोसीजर. 3 पॉइंट बियरिंग अगर बना रहे हो, यू डोंट एक्सप्लेन वी आर प्लॉटिंग द फर्स्ट बियरिंग, सेकंड बियरिंग, थर्ड बियरिंग. नो, नॉट रिक्वायर्ड. बट एनी कैलकुलेशन विच यू आर डूइंग, if you are plotting a horizontal angle, you mention there the difference between these two bearing equal to the horizontal angle, so show that difference. Anything which is being calculated should be shown in the answer sheet. Clear beta? Understood? Okay.
सर ये एक चीज पूछनी है सर, जो आपने सर PN2 लिया सर D के केस में सर, आपने उसको A पे ट्रांसफर किया सर. इसमें जैसे हमने रिडक्शन ऑफ स्पीड के लिए आपने सर वो OW वाली लाइन पे कट कर दिया. अभी सर इसी केस में सर अगर हमको ऑल्ट्रेशन भी ढूंढना होता और हम सर डब्ल्यू को खोलते सर, ओ डब्ल्यू जितना खोल के डब्ल्यू पे कंपास रखते, फिर सर
Right.
वो अगर उसको करते होते तो वो कैसे करते सर हम?
अभी करते हैं बेटा, अभी ऑल्ट्रेशन वाला भी इवैल्यूएट करते हैं, अभी तो देखा ही नहीं.
ठीक है सर.
Let's do that. Now let's evaluate a third option which can be picked up from this diagram. The third option which is available to us is an alteration of codes to port. So you see here, this was our initial course vector for target delta. You can follow the laser pointer. For target delta, our ship course and distance vector was W Oscar. Now, if instead of W Oscar, if we steer a course of W to this particular point here, O3, you see this is the arc which we had drawn representing our distance in 12 nautical miles, and this was the line of approach, Papa November 2 line of approach drawn at point A. They were intersecting at this particular point. We name it as O3. So if own ship alters course to WO3, then WO3A would become our new triangle. O3A would be the new relative line of approach. Effective at 1016, that means at point Papa, this relative line of approach would take the target on Papa November 2 track, and it will have a CPA of 2 nautical miles. This option is also available as per radar plotting, but this option is prohibited by ROR Rule 19. Any alteration of course to port is prohibited. So we cannot take this option. WO3 option is not allowed.
सर एग्जाम में कोई एक ऑप्शन करने से चलेगा ना? सपोज आई शो अल्टर कोर्स टू स्टारबोर्ड, अनदर गाय इज शोइंग रिडक्शन ऑफ स्पीड, एंड थर्ड गाय इज शोइंग बोथ द ऑप्शंस. सो एग्जैक्टली व्हाट वी हैव टू डू? ओनली वन ऑप्शन इज इनफ?
नो बेटा, आपको सारे ऑप्शन पहले तो निकालने हैं. जैसे हमने इसमें 3 ऑप्शन निकाले. वन वाज ऑल्ट्रेशन टू स्टारबोर्ड, सेकंड वाज रिडक्शन ऑफ स्पीड, थर्ड वाज ऑल्ट्रेशन टू पोर्ट. इनमें से एक तो सीधा रूल आउट हो गया, ऑल्ट्रेशन टू पोर्ट इज नॉट अलाउड. अब जो बाकी के दोनों हैं उनको भी इवैल्यूएट करते हैं. सो लेट्स इवैल्यूएट देम, सी व्हिच वन इज बेटर आउट ऑफ देम.
ओके सर.
So we have 2 options now available to us. One
Sir,
is alteration of course to starboard by 77 degrees. Second is reduction of speed to 2 knots. Now among these 2 alternatives, reduction of speed is certainly preferable and recommended in this case, because in restricted visibility, it is always more prudent to reduce the speed than to alter the course of the ship drastically. We need to have an alteration of 77 degrees to starboard. Now, this kind of a bold or drastic alteration will not only take longer to execute, it will take much more time to execute, but may also result in a close quarter situation with some other ship. So reduction of speed on the other hand will be effective, will be much quicker, and is also recommended. In restricted visibility, reduction of speed is always preferable and will keep the ship safe. So out of these options, the recommended option is reduction of speed to 2 knots and making the required CPA, having the required CPA with both the targets.
Sir,
go ahead, beta.
I'm sorry, sir, but I don't agree with this option in reduction in speed, because it will take a longer time, and also we will compromise on the maneuverability of the vessel.
Okay beta, okay. Now ठीक है, दोनों को evaluate करते हैं. One is you are saying that reduction of speed will take a longer time. Now beta, in restricted visibility, we are supposed to keep our engines on standby. They should be ready for maneuvering anytime. So
considering the
reduction,
present speed is at 15 knots.
right,
Our ship is not at maneuvering, it is given as 15 knots. So coming down from
right,
15 to 2 knots will take a longer time than alteration by 77 degrees.
right. Okay, all right, accepted. अब तुम्हारा ऑप्शन कंसिडर करते हैं. लेट्स से यू चूज और to do a starboard alteration. Now, if you do a starboard alteration, beta, let me show you another diagram where all three ships are shown. Okay, इसमें हमने ships की location नहीं दिखाई है. I will show you the position of the ship. Give me a minute. Can you see own ship, beta? Own ship is steering 240.
Yes,
Right.
sir.
So this is how own ship is. Let us plot target Charlie also. Target Charlie is steering 180. So the course is 180. So you can see target Charlie. This is how the target Charlie is coming in. Let's now show target Delta also. This is how target Delta is coming in. Right, beta?
Yes, sir.
Now you see, if you alter to starboard by 77 degrees, one, the rate of approach will become very, very less, and you will have to go off track for a very long period of time. Do you see? Both Delta and your ship are having speeds of 15 knots. दोनों की speed 15 knot है बेटा. You can check. Your speed is also 15. Target Delta speed is also 15. So if you alter to starboard and you wait for target Delta to overtake you and go ahead before altering back to your course, imagine how long will you have to go off track.
Okay, it is 10, 12 and 10 for 10, 24. The plot, as per plot D, earlier the target D was coming to us at 1024. The CPA, the TCPA was 1024. And
That's
if
right,
we
beta.
and if we alter to starboard,
Right.
so then we have to calculate again. But it won't be means like 10 maximum. It will go to 1030. I would say.
No, 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 no. You do that and check it, बेटा. आप इसको चेक करना कि अगर आप starboard alteration कर लेते हो, what will be the new TCPA?
It
The
becomes
new
parallel
TCPA.
to target D, sir. So and again it takes a lot of time for us and we cannot alter to port later.
Exactly. That's right. If you see, beta, target Delta is steering 351. Okay.
Mhm.
And if we alter by 77 degrees, just add 240 to 77, that comes to 317.
317, yes.
So target Delta going on 351, you are going on 317, both moving at 15 knots. The TCPA will be very, very long.
सर इस क्वेश्चन में अगर हम रिड्यूस कर देते हैं स्पीड सर, बाद में तो डेल्टा वाला तो स्टारबोर्ड ही रहेगा ना, क्योंकि वो हेड ऑन है सी पे.
ओके, देखो बेटा, बड़ा सिंपल इशू है. आपका शिप 240 की डायरेक्शन में जा रहा है. ये दोनों शिप बेसिकली आपके बाव के आगे से क्रॉस करेंगे. अगर आप अपनी स्पीड को रिड्यूस कर देते हो, दैट इज द इजीएस्ट ऑप्शन अवेलेबल टू यू. You can visualize it very easily. If you stop your ship here, target Charlie will go on its way, Delta will go on its way, both will cross from your bow and your track will become clear. Let both of them cross and then proceed ahead.
आई थिंक सर इसमें बेटर ऑप्शन होता कि हम ये टीसीपीए कैलकुलेट करते नया वाला और वो कंपेयर करते.
Okay, you can do that.
अगर हम लोग स्पीड को ऑल्टर कर रहे हैं और मतलब स्पीड रिड्यूस कर दिया हमने और उसके बाद वो उतने ही टाइम लगा जितने में ये हमारा बाव क्रॉस कर रहा है, या उससे ज्यादा टाइम लग रहा है, कैसे भी.
ओके ओके बेटा, देखो आप इन दोनों को भी इवेल्युएट कर सकते हो. अगर आप स्पीड रिड्यूस करते हो, योर वेक्टर बिकम्स WO2, करेक्ट? And the rate of approach is basically represented by O2 to A, O2 to 1012 position of delta.
Correct.
Right? So there is not much difference in the rate of approach by reduction in speed. But if you do starboard alteration, the rate of approach becomes even lesser. Getting
vector
it,
length
beta?
is not vector length is not that different. What I am trying to say, no sir, that
Okay,
reducing
just
the
give me a
speed
minute.
to such low level.
Just give me 1 minute. यहाँ पे वेक्टर लेंथ तुम्हें सेम दिखाई दे रही बिकॉज ऑफ ए प्लॉटिंग एरर. दिस इज डिजिटली जनरेटेड इमेज. मैं अभी तुम्हें इसकी एक्चुअल इमेज दिखाता हूँ. गिव मी अ मिनट, आई विल शो यू. One minute, let me see the image. ओके, ऑल राइट. ये देखो बेटा, ये इसकी एक्चुअल इमेज है. ओके, नाउ इफ यू सी, you do a starboard alteration, the rate of approach is this one, O1A, and if you do a reduction speed, this is the rate of approach. This is the actual plot. So अगर आप इसे actually भी plot करोगे तो आपको difference दिखाई देगा.
In actual plots, the speed after reducing is coming 1.5 knots.
Yeah, the speed is coming as 1.5 knots.
Yes, sir, 1.5.
Yes, sir, 1.5. Yeah.
Okay, beta, all right. That's perfectly okay. No issues. Getting it, beta?
यस सर. तो सर फिर आंसर में ऐसा मेंशन कर सकते हैं साथ में, रेट ऑफ अप्रोच विल रिड्यूस, विल हैव टू स्टीयर 77 फॉर सो लाइंस फॉर लॉन्ग
That's
टाइम.
right. You can, yeah, you can mention that, beta. अगर आप starboard alteration करते हो, this is how the situation will pan out. Both ships moving at a speed of 15 knots and going like this.
सर ऐसा कोई मतलब सैंपल है क्या सर, आंसर शीट में कैसे लिखना है, कोई नोट्स वगैरह ऐसा कुछ?
बेटा मैंने बता तो दिया कि जो भी चीज कैलकुलेट कर रहे हो कैलकुलेटर में वो लिखनी है.
ओके सर.
तो कौन सा पेज नंबर है बुक का ये क्वेश्चन?
दिस इज ऑन पेज नंबर 252 बेटा.
थैंक यू सर.
राइट बेटा, क्लियर?
Clear, sir.
Okay, all right. Okay, all right.
Sir, the exam, we have to do this in within 20-25 minutes, no? All this floating thing.
That's right, beta. Every question you get a time slot of about 20 minutes. So you have to complete in 20-22 minutes.
Okay, sir. Seems this kind of problems are time consuming.
No, it seems in the beginning. अभी तो आज ये आपने पहली बार की है. Yesterday we did basic radar plot. आज हमने एडवांस प्रॉब्लम्स की हैं फर्स्ट टाइम. So what you do is you practice these couple of problems which I have told you. And एक और प्रॉब्लम मैं आपको भेजूंगा. I will send you a screenshot. So do these three, make a plot, practice them. And इन तीनों को करने के बाद once you are comfortable and confident in these three, you can jump into past papers and start doing plotting questions anywhere. You can pick up the question and start doing them. मेरे पास कुछ एक solved questions पड़े हैं बेटा जो पिछले papers में आ चुके हैं. They have been solved by candidates. So there can be a slight difference in the answers. Okay, I have not verified whether they are accurate or not, but if you want, I can share them with you and you can practice them.
Yes, sir.
So
Yes,
that will
sir.
cover.
Please, sir.
Yes, sir.
Okay,
Please
I'll do
share
that.
it, sir.
सर
So
एक
that
बार
will cover a lot of questions which have come in the past.
सर एक बार वो परफॉर्मेंस डिले और हेड रीच पे भी अगर करवा देंगे क्वेश्चंस तो सही रह जाएगा.
Okay, all right. You have questions on them, beta? हैं उनके questions?
सर एग्जाम्स में आते
I've
हैं
seen it earlier, but I don't have it right now. I have to find
Okay,
it.
Sir, can you give me 2 minutes? I'll check out. I had somewhere.
no problem. Take your time and performance delay and head reach. ये दो topics आपने बोले हैं ना?
Yes, sir.
ओके व्हाट आई विल डू इज मैं इन दोनों टॉपिक्स पे परफॉर्मेंस डिले और हेड रीच पे आपको एक छोटा नोट्स भेजता हूँ. ओके, नोट विद ए डायग्राम. सो जस्ट रीड दैट. You should be able to attempt any questions which are coming in these two topics after that.
Okay.
Okay.
Yes.
सर एक परफॉर्मेंस डिले से याद है सर आप बोले थे परफॉर्मेंस स्टैंडर्ड भेजने के लिए इक्विपमेंट्स के वो कब तक मिल जाएंगे
Okay. ठीक है बेटा. I'll send that today itself. Okay.
हाँ जी सर थैंक यू
Okay. So you can keep going through those standards as we cover the equipment one by one. Start going through them. उनको मेमोराइज
yes,
करना
sir.
पड़ेगा. So जो एग्जाम
Yes.
फॉर्मेट में जितने इक्विपमेंट्स लिखे हुए हैं, keep going through them one by one and start memorizing.
हाँ जी
ओके तो आज आपके पास जो होमवर्क है, वन यू हैव टू प्रैक्टिस दीज 3-4 क्वेश्चंस व्हिच वी डिड इन क्लास. Once you are comfortable and confident, you can jump into past papers. I am sharing some solved past paper questions. Verify that the questions have been done accurately. Okay, most of them are accurate. I have checked them, but there can be slight mistakes here and there. So you can start working on them. You will not be able to complete all of them in a day. So keep on doing 1-2 questions per day and start solving them.
Sir, is it
Right.
over now, or we start tomorrow with magnetism or radar plotting only, sir? Tomorrow.
रडार प्लॉटिंग फ्रॉम माय साइड इज डन बेटा. अब आप मुझे जो जो डाउट्स बताओगे उसी डाउट्स को मैं एड्रेस करूंगा. अदरवाइज रडार प्लॉटिंग टॉपिक इज कवर्ड. एंड टुमारो वी विल स्टार्ट विद मैग्नेटिक कंपास. हमने बेसिक्स ऑफ मैग्नेट्स किए थे, कल उससे आगे शुरू करेंगे. सो दैट इज द बिगेस्ट लार्जेस्ट टॉपिक इन नेविट्स. सो कल उसे शुरू करेंगे. लेट्स सी हाउ मच